Hey everybody, the purpose of this video is to get you guys some solutions to our little matched pair quiz. Make it a little bit easier to see. Nope, a little too big. We got 6 students who took a before and after assessment. If the numbers after are larger, that implies that the assessment raised, it looks like reading speed and comprehension. So there's our metric. We're trying to increase those things. So to see that statistically, we got to run a matched pair t-test. So that's a t-test, which is exactly the same, but we have to pair the student because you've got a student matched with themselves. I'm going to do L1 minus L2. You know what? No, let's do L2 minus L1, although it does not matter, and I'll explain why as we go through this. I'll do L2 minus L1. I think that'll make more sense for you guys because if the scores went up, we're going to get positive values over here if we do it that way. If they went down like they did here, we got negative, and you can see that's why Miranda and Hannah both went down. Whereas the other students went up. Bonnie jumped up by 7 points. None of that matters, of course, except the average. We're looking for the average. And this is a very small data set, size 6. Technically speaking, what you probably want to do is check for normality. I mean, that looks fairly normal. You got a box plot with no outliers, but honestly, with a sample size of 6, it's going to be kind of tricky without. We could run a normal quantile plot like you did in your second project instead of a histogram. That might make a little more sense. Looks like almost like a straight line. If we pull plot 2 off and rezoom stat it, I mean, it's hard to tell. Yes, it looks like a straight line with enough noise with a sample size of 6. It would be helpful if TI put some error bars on there to see how far out we've gotten from a straight line. You know what? Don't even worry about it. Don't even worry about it. Let's just run the numbers and see what it tells us. We are definitely testing an average. And in this case, we're testing the average difference between the pre and post tests. And I spelled everything wrong. There we go. That's what we're testing, the average difference between those two. As far as what we want to see, well, if we want, this is where it gets, you have to be very, very careful here. If I want to see that the test, the assessment was successful, what I want to do is I want to make sure that scores went up on average, that they went up. So I want, on average, the scores to be above 0, because if there's no difference at all between them, you'd have a 0 difference. If it were a negative difference or a null hypothesis is mu equals 0, no difference whatsoever. Technically, it's less than or equal to 0, right? I mean, technically speaking, if you go with mathematical exactness, it's less than or equal to 0. But equal is just fine. But this is what we're testing. All right. So type 1 error would be saying the scores went up when, in fact, they didn't. That'd be a type 1 error. Let's try spelling a few things correct as well. Saying the scores went up when, in fact, they didn't. Make that red. And a type 2, saying the scores went down or didn't go up when in fact they did. Your choice on which one is worse. I don't want to paint it with my opinion. So your choice on which one is worse. We're testing a T distribution. I've erased some boxes down here, unfortunately, but that's okay. Let's test it with a t-test. We got data, we sure do. We're testing against 0, we sure are. Our data list is in L3. That's where I did it. The frequency is going to be 1. Now, I am definitely testing an average of 0. I want to pause here and mention something. If we had subtracted L1 minus L2, we'd be testing less than mu naught, because then all of our signs would be negative of what they are right now. So just keep that in mind when you're doing these matched pair tests. All right, well, look at that. Looks like we got a test statistic that's within 1 and a little over 1 standard deviation, 1.2-ish, somewhere in that neighborhood. 1.2-ish, somewhere in that neighborhood. We got a p-value of about 15%, which is not small enough statistically to arouse suspicion. Not small enough to statistically arouse suspicion. So it does not appear at 95% confidence that the scores have been raised by the course. Have without a B. And we could have made a type 2 error. Okay? Now, the problem with this test, obviously, is the fact that there are 6 elements in it. it would be called a very non-powerful test. I don't think anybody tried this quiz. I'm not sure, but we're going to reanalyze this one on your next exam. We're going to look at the same data set, and we're going to do error analysis at a very, very careful level, get some numbers, type 1, type 2 errors, and actually try to minimize the chance of a type 2 error via proper size sampling. So we'll leave it at that for now, but hopefully this got some solutions for you.